Perfect problem for solutions. We're asked to solve this absolute value inequality. The way we do that is we'll first look at an absolute value equality and try to solve this guy here. And we can solve this, get the absolute value all by itself. And then the way you can get rid of the absolute value is by kind of considering two cases, either 4 minus x equals 8/3 or 4 minus x equals negative 8/3. So let's see here. I guess you could subtract 4 from both sides. 4 is the same as what? Negative 4 is 12/3. So 8/3 minus 12/3 is negative 4/3. So x is equal to 4/3. And over here, if you subtract 4 from both sides, you get negative 8/3 minus 12/3. So negative x is negative 20/3, so x is positive 20/3. So what we've done here is kind of created a number line. We got 0 over here, 4/3 here, and 20/3 way out here. And we've created 3 regions, one out here, one in here, and one out here, that we'll have to test to see if they work and they solve this inequality. So pulling a number from region 1, maybe x equals 0 would be a good choice. That'd be the easiest to do. Try plugging in x up here. So is 3 times the absolute value of 4 minus 0 really greater than 8? Question mark. Absolute value of 4 minus 0 is the absolute value of 4, which is 4. 3 times 4 is 12. Maybe I'll write 3 times 4. And that is greater than 8. So that means that, in fact, 1 works. The numbers in this first region are solutions to this inequality. Second region, numbers between 4/3 and 20/3. 4/3 is a little bit more than 1 1⅓, so maybe we'll choose x as 2. You could have chose other values, but that's the one I chose. So it's 3 times the absolute value of 4 minus 2. Question is that greater than 8? Absolute value of 4 minus 2 is 2. Absolute value of 2 is 2. So 3 times 2 greater than 8? No, that's 6. 6 is not greater than 8. So 2 did not work. And finally, our third region out here, numbers bigger than 20/3. Just to find a round number in there. Let's see, this is a little bit less than 7. Maybe I'll choose x as 10 to get a nice round number. So I get 3 times 4 minus, the absolute value of 4 minus 10, is that greater than 8? Question mark. Well, let's see, the absolute value of 4 minus 10 is the absolute value of negative 6, which is 6. And sure enough, that is 18 is greater than 8. So these do work. So my answer would be everything from negative infinity all the way up to 4/3. This is region 1 here. And then also everything in region 3, everything from 20/3 up to infinity. And note I use parentheses here instead of brackets because it's greater than, not greater than or equals to. Alright, it's a lot of work, and now we gotta do it again. Okay, absolute value, so what we'll do, exact same steps. Maybe I can go a little quicker this time. Divide both sides, whoops. We'll first set it to an equality. Divide both sides by 2. And so what that gives us is 2 cases, either 3x minus 4 equals 13, or 3x minus 4 equals negative 13. So 3x equals 17, x equals 17/3. 3x equals negative 13 plus 4 is negative 9, so x equals negative 3. So again, I get this number line here. I got negative 3 and 17/3. And that gives me these three regions. 1, 2, and 3. And what I'm going to do is choose numbers from each of these regions. So from this first region, maybe I'll let x equal negative 5, whatever. So 2 times the absolute value of 3 times negative 5 minus 4. Question is that less than or equal to 26? Well, let's see. 3 times negative 5 is negative 15. Minus 4 is negative 19. So this is 2 times the absolute value of negative 19, which is positive 19. And we want to know, is that less than or equal to 26? 2 times 19 is 38. That's not less than 26. So that's not true. So that looks like 26x now. There we go. That's not true, so the things in 1 are not solutions. No. Alright, let me switch colors here. Something from the middle region, probably easiest to let x equal 0. And then we have 2 times 3 times 0 minus 4, absolute value less than or equal to 26, question mark. 3 times 0 is 0, so the absolute value of 0 minus 4 is just 4. 2 times 4 less than or equal to 26. Yeah, that's true. 2 times 4 is 8. That's definitely less than or equal to 26. So these guys work. And finally, over here in region 3, a number bigger than 17 thirds, which is a little less than 6. Let's let x equal 10. So what we have is 2 times 3 times 10, 30, minus 4. Is that less than or equal to 26? Well, let's see. The absolute value of 26, 30 minus 4, is 26. And 2 times 26 certainly is not less than or equal to 26. This is 52. So that does not work. So these are not solutions. So my answer is the only things that work are the things in region 2, which is everything from negative 3 up to 17 thirds. And the point I want to make is that I use brackets, not parentheses, because I have less than or equals to here. Okay, so now what I have to do is find the intersection of my answers, and then later I'll have to find the union of my answers. So this is part A up here. Let's see, we have negative infinity all the way up to 4 thirds, and then 20 thirds all the way up to infinity. And my answer is kind of all of this stuff and all of that stuff. Okay, my answer to part B, I could create a number line. And I see negative 3 over here somewhere. 17 thirds, that's less than 20 thirds, so I'll put it right there. And now I want everything, including these points, that's in between these guys. So to find my intersection, I need to know what things are in the top set and in the bottom set. To be in the intersection, you have to be in both. That looks like it's everything from negative 3 all the way up to 4 thirds here. So my intersection is negative 3 up to 4 thirds. I want this one closed and this one open because this circle's closed and this circle's open. I should change this. This should, and for you it will, say express the union of the answers to part A and part B. And I can do that. It's pretty similar to how we found the intersection, except now we don't need things that are in both sets. We need things that are in one set or another. So in that case, it looks like it's everything from 17 thirds to infinity. Right? 17 thirds to negative 3 is in this bottom set, and then everything further to the left is in the top set. And again, all of this stuff. So my union would be everything from negative infinity all the way up to 17 thirds. Union, everything from 20 thirds up to infinity. this one closed, this one open, because this circle's closed and this circle's open. These are all meant to kind of line up. Maybe that helps a little. But this is the answer for this last part, and that, maybe I'll write union, is the end of this kind of long problem.